Hello friends, in this sessions we are going to learn how the battery charging section works. So we are going to study the detail of the circuits, how the individual MOSFETs are works and how battery charge and how the input voltage coming from the adapter, how the voltage is controlled. Okay, so first we will see what is a battery and how many voltages are there at the battery connectors. So these are the battery. The normally in laptop the Li-ion cells are used, and each Li-ion cells the voltage is somewhere around 3.7 volt and 2 ampere. Okay, so normally 3 cells are connected like this. So if you add 3 cell individually like in series, the voltage will be the added like 3.7 plus 3.7 plus 3.7. In series the voltage will be added and the current is same, like if it is a 2 ampere here, 2 ampere here and 2 ampere here, that means the total current is 2 ampere only, but the voltage will be added like it will be 11.1 volt. And if we add 3 more cell like this, and if you connect all the total combination to the parallel connection like this, then the output voltage will be 11.1 volt and the current will be like this bank will give 2 ampere and this bank will give 2 ampere. The total current will be the 4 ampere. So normally in the laptop battery, the output voltage is around 11.1 volt approximately. It's depend, of course, it's depend on the how many number of cells connected in series or number of cells connected in the parallel. But in normal laptops, the voltage is somewhere around 11.1 volt. So that is one thing. Another thing is there is a bus is called the SM bus, or it's called the I2C bus. SM bus or the I2C bus is basically is a communication protocol between the battery and the super IO. Like this bus is communicate with the battery, and whatever the information is there from the battery is informed to the SIO. Okay, so SIO communicate with the battery via this bus. This SM bus have a two wire, one is called the clock and another is called the data, and this total communication is a two-way communication, like SIO also send the data as well as the battery also send the data, like a two-way communication. So these are the two wire. The another signal is there, the temperature. Temperature means when the battery charge, so the SIO monitor the temperature of the individual cells. So that SIO monitor the temperature of the battery. And the next is called the system detect. The system detect is not always there on the all laptops, like Dell laptops and some another laptop use this signal. It's called the system detect. And system detect means what? When this battery is connected to the motherboard, then only he enable the output, otherwise their outputs are closed. So these are basic structures of the battery. So there is a circuit inside the battery that control and manage the battery voltages and the current. Okay, so now we'll go back to our main circuits. So this is my main circuit. So here is my battery and here is my DC inputs where I connect the adapter. The normally adapter voltage somewhere around from 19 to 20 volts, depend on the again model to model. Some laptops give the 18, some laptops give the 19, some laptops give the 20 volt. Okay, and these are the two MOSFETs. Okay, here you can find there are total 5 MOSFET, 1, then 2, then 3, then 4, then 5. These are the total 5 MOSFETs are there, and all these 5 MOSFET control by this chip is called the battery charging chips. The battery charging chips is a chips to control and manage the battery voltage and control both the inputs and output voltages. Like the voltage is coming from this side, is from the adapter side, and voltage coming from the battery side also. So it's like a traffic police who manage the traffic. Similar way, this battery charging chips controlled by this output input and output voltages, and their manager is this chip. Is called the super IO, super input output controller. Okay, so and another thing is this chips require a power to work. Okay, and wherever you can find a dot, that is pin number 1. So the pin count by this chip is wherever the dot, like here is a dot, so that this pin is 1, then the 1, then 2, then 3, then 4, then 5. The counting is anti-clockwise. So you have to count anti-clockwise, and each pin have their own names and their own unique features, like you will find the DC in, you will find the AC in, you will find the current sensing, you find the assembles, you find the AC OK. So there are different signals. So suppose this chip is a 24 pin chip. So 24 pin chip per 24, each pin have their own names and own purposes. Okay, and this pins either may be inputs or may be outputs. Okay, but the first thing is every chips require a power, and that power is called the DC in or VCC, something like that. This is a power. Okay, so now we'll start our animation. So when I connect the adapter, suppose my input voltage is 18, and when I connect the adapter like this, my 18 voltage travel and stop here, and it pass here, and then it goes to here. Here is a p channel MOSFET. Okay, now you will ask why the p channel MOSFET is used here. So p channel MOSFET is like, there are two types of MOSFET. One is the n channel and another is a p channel MOSFET. N channel MOSFET, how the N channel MOSFET is work? When we trigger a positive current to the gate, then it's connect. And if it is a P channel MOSFET, when we apply a positive current to the gate, then it disconnect. Like the MOSFET is like a switch, just the other switch, the mechanical switch. Similarly, the MOSFET is an electronic switch. There is a three legs called that gate, drain and source. And source and gate is a connected to each other when we apply the current to the gate. Okay. So now here is a P channel MOSFET means, here is a P channel MOSFET means when there is a no current at the gate, this is a gate, when there is a no current at gate, then the battery current will travel from here, then from here, then from here, and then is out. This, suppose this is my output. Okay, when the no current. Okay, now if I apply the current to the gate, suppose when I connect the adapter and my 18 was travel to this gate, that time it disconnect this particular MOSFET, the MOSFET number 5. There is a P channel MOSFET, it disconnect. So the adapter, so battery voltage won't travel from the drain to source. Okay, though it will stop here. Okay, so that is one thing. Now the second thing is, this voltage, when I connect the adapter here, this adapter voltage goes to this chip at its DC in pin. Okay, the DC in voltage will goes to this battery charging chips. Okay, now when as soon as this chips get the power at a DC in pin, then this chip started working. Okay, and then here is a two divider circuit, R1 and R2. Two resistors are connected in series, and there in junction one test point is there, and this test point is called AC in, or it's called the adapter current in. So why it's so it is for that when we apply the current to this DC jack, then this divider circuit divide the circuit, the 3 volt will be generated according to the Ohm's law, and this 3 volt given to this AC detect pin. Here is the AC means not the alternating current, here the AC means adapter current detect or the adapter current in, and if this pin adapter current in pin get the 3 volt, then this chip will come to know that adapter voltage is present. It's something like that. Suppose we are going to someone house, and if we click the button or we knock the door, then that particular person will come to know that the someone is outside, and he open the door. So similarly, at this AC in pin, he received this AC in pin 3 volt here. That means that this chip will come to know that the adapter current is present. That is okay. So it's something like that. So as soon as he receives the 3 volt, then what he will do is that this chip will drive these two gates. So he send out one signal that is called the AC current drive. So he send out generate the 18 volt. If this MOSFETs are N channel, then he generate the positive volt, something around 18 voltage, and he send out the 18 voltage from this pin and given to this two gates. there are two MOSFETs and is given to this gate, something like we are opening the door. So this 18 volt travel to both the gate, and then both the MOSFET will turn on, and then the voltage which is stop here, which will travel from this side to this side and this side to this side and travel via this current sensing resistors and just entering into the laptop. So friend, I hope you understood how the circuits work. That means when we connect the adapter, my voltage will travel from this side, and when I remove the adapter, at that time this P channel MOSFET started conduct and the voltage will travel from this side. I'll show you again the same animation. So now if the voltage is not there at this adapter, then the voltage will travel from battery side, cross this MOSFET number 5 and entered into the laptop. And when I connect the adapter like this, and this voltage will disconnect the battery voltage and entered into the laptop like this. It generate the AC detect signal, and then this chip drive this AC drive current to the both the gate, and voltage will travel from this drain to source, then source to drain, and travel via this current sensing resistor and then send the output. Now here is called the current sensing resistor. This resistor's value is very minute. Its value something around 0.02 ohm, which is a very minor value below this 1 ohms. Okay. So now why these resistors are used here? These resistors are used here basically to check the current, how much the current is flowing. That means according to the Ohm's law, when the voltage traveling from here, some minute current will some minute voltage will be dropped across this resistor, and from that minute voltage drop, this chip will come to know that the how much current traveling from this resistor. So he calculate like that. Okay, and then he will come to know when I turn on this both the gate, the voltage entered into the laptop and how much the current is passing how much current is passing from the adapter. Okay. The next thing is this chip will inform his boss. So the SIO is a boss to the battery charging chips. So once the voltage is entered into the laptop, and then this chip inform SIO that the adapter current is present, that he generate this ACOK signal. Here is the ACOK means the adapter current okay, or it's called the AC present, or the adapter current is present. So he generate a binary 3 volt here, and this 3 volt given to this ACOK pin on the SIO. So okay, so if the 3 volt is come here, then SIO will come to know that the adapter current is there. So after that, SIO come to know that now the laptop is working on the adapter. Then here is the SM bus, is a system wire system management bus. I already told you the system management bus is a two-wire communication protocol. Clock and data is a bidirectional bus, and here the SIO and the battery charging chips communicating with each other, and here the battery charging chips tell the SIO that the adapter voltage is there, and then this SIO will start communicating with the battery. It's like this, started communicating with the battery and informing the battery that the source voltage is there, that means the adapter voltage is present, and now do you want any charge, because the battery is something like a godown. Okay, so if this is a supplier and here is a godown, if the supplier is failed to generate the voltage, or if supplier failed to supply the current, at that time the battery so it's called battery started sending the voltage. So something is like that. So now SIO started communicating with the battery and just asking the battery whether you need a charge, and if the battery require a charge, battery also tell this SIO, yes, I need a charge. Now the battery need 11.1 volt for the charging current. Okay, so this junction is called the bidirectional. That means the voltage coming out from here also and voltage entering from here also, like that. So when the battery tell this SIO that he need the current, at that time SIO ask SIO inform this battery charging chips that he give the command to these chips and saying that he generate the voltage for the battery and give 11.1 volt to the battery, because my adapter voltage is something around 18 to 19 volt, and here so my battery need 11.1 volt. So I can't give 18 or 19 volt directly to this battery connector. So what I had to do, I had to reduce this 18 voltage to the 11.1 voltage. For that, we have the circuit here, it's called the buck converter. So this is a buck converter. These are two MOSFET, then coil and the capacitor and chip inside these chips. So here is a single chip, here is a buck converter. So once SIO ask the battery charging chips to generate the charge, and then the battery charging chips started pulsating this two MOSFET, generating pulsating this two MOSFET, switching this 18 volt, convert this 18 volt into the 11.1, filtered by this capacitor and entering via this current sensing resistor into the battery, and then the battery started charging. And as soon as the battery charging, the battery again from this port is informing to the SIO that is getting the charge and how many number of percentage he charged. As soon as the battery is full charge, then battery close their door and inform the SIO that he is fully charged, and then SIO stop this charging, and in this way this circuit work. So friend, I explained theoretically how this section work. Now we'll understand how to rectify the problem or how to solve the problem if this section is faulty. Now if this section is faulty, there are a number of problems can be appear in this laptop. First, if the laptop is not working on the adapter, if it is working on the battery, if it is not working on the adapter, then possibility that it could be this two MOSFET may be faulty, or maybe this DC jack is faulty, or this chip may be faulty. Okay. Now the second problem is if the laptop is working on the adapter but not working on a battery, then possibility could be the battery may be fault, or if the battery is okay, then this MOSFET number 5, the speed channel MOSFET may be faulty. Problem number 3, if the battery is not charging, laptop is working on adapter as well as the battery, but battery is not charging, then the possibility could be this two MOSFET or this battery charging chips. The next thing is the laptop is not detecting the battery at all. So that could be this communication is failed, this SMS communication is failed between the battery and the SIO, or this resistor, this battery present resistor or the battery present circuit, something is a problem. So that the resistors may be open. So you have to check that. So if you understand this problem, then you can able to rectify the 4 problems in the laptops.